So a compressed spring shoots a ball to the right. The ball is initially at rest. So these bar charts, like, they're kind of useful. I mean, they give you a visual idea of what's going on with momentum. But so we talked about how you have like an initial momentum, and then there's an impulse. That's the same as the change in momentum, and there's the final momentum. So these bar charts are like, you start out with the initial momentum, so maybe it has like this much, and then you put the change in momentum. Maybe it's negative, it goes like that. And the final momentum, they just cancel each other out, so it'd be like this. Or if this one's positive, you basically just add up the first two to get the last one. Maybe that one looks like this one would look like that. So, like with the first one, oops, it says there's a ball initially at rest. So how much momentum does something have if it's at rest? Yeah, so it'd just be 0. And then what does it do? Shoots the ball to the right. So what would your J be? Yeah. So you just draw whatever size you want it to be.
Oh, really?
Yeah.
What are these for, though?
That's to draw the graph on.
Oh, you draw it on this.
Right, yeah. So you just like draw up to whatever lines you want.
Okay, so we don't do anything with this space.
Let's see. No, I don't think so.
Explain or anything.
No, you could probably write like P initial is 0. The impulse would be positive, but I don't really think you need to.
So you draw it, whatever.
Yeah. So you just draw it that way, and then the next one would just be the same, right? Because it doesn't give you numbers or anything, so it's just a scale thing.
Okay. Rubber ball is tossed straight up and bounces off the ceiling. Consider only the collision with the ceiling. Straight up and bounces off the ceiling. So collision with the ceiling. So the P, the initial that'd be positive.
Yeah.
And then J be negative.
Right. And this,
Oh, does it?
yeah, you just have to make it compare to the other one, right? So if it bounces off the ceiling, what does that do?
It's coming back to where it was.
Well, yeah, it's going to bounce back. So what would the final velocity be?
0. Would it?
Well, if it hits the ceiling and then bounces back down,
Would be negative.
yeah. So you'd end up with a negative final momentum, right?
So this would be bigger.
Yeah, so this has to be big enough to cancel out the first one and then get that. So that's what the lines are there for, is so you can give it like a scale. Okay? So that's if you throw a ball up and it hits the ceiling. What's the last one?
A clay ball is tossed straight up and sticks to the ceiling. Consider only the collision with the ceiling. So this would be positive.
Right.
This be impulse would be 0.
Well, so the impulse
6.
is the change momentum, right?
Right. Oh.
So how much will it change the momentum?
Change it to 0. So it'll be negative.
Right. And the final will be 0.